Hey guys, welcome to my video. And as you always know, right, my name is James. Today I want to talk about how electricity makes light. I prepared you something on a practical experiment I did yesterday, and I found by that practical experiment, I found something very interesting, which I will tell you right here on the board. So today is about how electricity makes light. What is really important is that you will hear some keywords which I will go later on it, and because I have a theory, and that light bulb actually confirms for some reason my theory. So here's a light bulb. Have that always in mind in the back during the video. So I ordered here in an order, the first experiment, second, and then the third. So you can make electricity. You can use, and electricity is a key thing. It's really a phenomenon, key thing, which you always have to. It's always good to gain knowledge into electricity. So electricity produces light, and how does electricity produces light, and what are the components and the factors to produce light? So it's actually really simple. My first experiment I did is just a battery, and on the battery, you see here is with the B and the red square. On that battery, you connect two wires on one side, each on one side, left and right? And between those two wires is a gap, which you will connect a thinner wire to connect those two big wires, or to those wires that are connected to the battery. And what happens is there's a little electricity flowing, right, through the wire, and in a thin wire, what happens is that the electricity produces a kind of a red light and a lot of heat, right? Maybe you can understand that, you know, when you have at home in the kitchen a toaster, and when you look in the toaster, you have this little wires, they glow red. It's a red light and it's extreme heat. So we know now that light can be red, the color red, and produce extreme a lot of heat, right? So that was my first experiment. A battery, I connected two wires on a battery, and I connected those two wires with a thin wire, and that thin wire became red, a light red, dark red, and a lot of heat. It produces a lot of heat. And that's it, period. There was not the real light what I was expecting, right? By the second experiment, I did the same thing, a battery, two wires on each side connected, and a thin wire that connected those two wires that are connected on a battery. And then I put the difference between the first, I put in a bottle, I put the two wires and the thin wire, so that part is in the bottle, and it's a little bit sealed here, right? So what happened here is that I wrote it down, because I always write down my practical experiments and write a protocol. So here, the difference between this experiment and the first experiment is that the wires and the thin wire that should produce light are in a bottle, right? So what happens is the light only stays for a few seconds, then it goes out, burned out quickly, because I think air was in it. So air is a keyword, a very keyword to remember, air. Then I did a third experiment, right, which you see here, the same procedure, battery, same two wires connected on the battery, and a thin wire that connects those two wires, and the electricity flows in that, right? What happens now is I put it in a bottle, but I took the air out. And what happens is interesting, and I wrote it down here, you know, I have here my notes, is that because I figured out, because on a third experiment, because of the air was removed out of the glass, the bottle glass, now it can stay constant as a light. This part, this is what you see, this glowing part. It stays there because in that glass, in that bottle, in that bulb, air is concealed out of the bulb, and that's why the wire in there because the wire in there is not surrounded and in contact with air. Now it will never melt, and it stays always glowing, and that glowing produces that light, right? So between these three experiments, I figured out that air is a very crucial and a very interesting factor in producing light. What you see here is a light through electricity. So light, that yellow light what we see here and everywhere, can only be produced when the wire is in a vacuum, in a no air room or space. And I found that very interesting because, as you know, when I understand the core and the principles how electricity produces light, what I do is, when I understood the core and the principles of a function, I adapt it, but I don't keep it that way, that I just adapt it. I try to apply it, and that's what most people cannot do for some reason. I don't know why. You have to apply it in your environment, in different fields. Now, the interesting thing is, what I figured out is, if that light can be dark red, a spectrum of light can be dark red and a lot of heat. This is over here, right? It's red heat, and there is no air. There's air around. There's air around, and it has that little wire. And the first experiment is dark red, and it produces a lot of heat, which you see in your toaster when you toast your bread, right? That's a light spreading I figured out. Then I try to put it into a room or into a bottle, and maybe I thought if there is no air, maybe it lasts longer. But then I figured out it's that the light only stays for a few seconds in here, right in here, in that glass bottle, and then it burns out quickly. And I think because there was still air in there, in the bottle. So when you take, what I figured out is that when you have a bulb or bottle that has no air in there, absolutely no air, it's vacuum, no air, then it's only glowing. It's only glowing the whole time. And that's something very interesting. That when there is vacuum, it doesn't allow to melt and just to burn out. So it keeps that status of glowing all the time. That's why you always see this light glowing all the time. It doesn't burn out. And when you have a bulb at your home and it doesn't work no more, it's because that little wire is disconnected, right? There is no currency flowing into it. But if it's connected, the electricity currency, then you see this bright light. But that part, which also looks like it's, if this part looks like you gotta see it like this maybe. This part and this part, you can see it as a zoomed in LED light. It looks like this, just in a bigger scale, right? It just popped on my head. Maybe you can visualize better. But there was still air in it, so it was glowing, and it melts, and then it was burned out, the wire. So there was just only just for a few little bit seconds, light, but then went out. And on the third experiment, there was no air. It was absolutely vacuum proof. There was no air at all, and it was glowing all the time. And it didn't melt down. That tells me that what I think, and bear with me with on that, because now comes the interesting part. Because I did these 3 experiments, I understood that electricity can produce light, but the components has to be vacuum sealed. It has to be in a vacuum area, in a vacuum space. Then it's glowing all the time because there's no air in it at all. But when there is air coming in, it's glowing, it's melting, and it's blowing out. Now, you understood now the principles and the core of that function, right? How electricity produces light, and the light can only stays when there is no, the light can only glow and holds that glowing when there is no air. But as soon air comes in, it's melting down, it's burning out, and it's done. If you understood that, that means you have adapted the understanding of this procedure. Now comes the application. I apply it. Now listen to this. The sun. I think that the sun, what we see in the sky, the sun is the reason why the sun is glowing and it stays as a glowing status like this, because there is no air. There is no air. The sun is in a kind of a vacuum area. That's why it keeps always glowing all the time. But I think when air would touch the sun for some reason, or it comes contact in the sun, I think that the sun will explode. That's what I think. I don't know, because I never did the experiment, but it would make sense with vacuum and the sun, because the sun is like this. You have to see it like this. The sun itself is like this thin wire. And if the sun can only stays glowing, which we see every day, is because the sun is in an atmosphere where there is no air. It's like a vacuum. And I think that's the reason why the sun is always glowing and looks nice, and the light produces this white light, it's glowing. But I think if air would come in touch with the sun, or air disturbs the sun area, then we will, I think, see an immense phenomenon that the sun will explode. Like it's melting down, like here on this experiment. It will melting down very fast, burned out, and it's a little light, and then it's burned down. Maybe that's the reason, or could be also another reason, that the stars what we see were all suns in the beginning, but somehow air touched it and then it exploded because it was no more in a vacuum environment, and somehow air touched it and then it exploded and it just disappears. Another interesting thing is what I figured out with no air and light. It's really interesting. It's really, really interesting. First of all, I think the reason why we see the sun that's glowing up in the sky is because there is no air in space, which we know it's like a vacuum. I think if there would be air coming in contact with the sun would explode for some reason, because I see here an experiment, the white light. The interesting thing is, if the sun is light, we perceive it as a white yellowish light. I know there are planets that they are red, right? That has a red light. But as I know from this experiment, a red light currents electricity produces in its way only a dark red light, but a lot of heat. But it has air around for some reason, similarity to air. And that reminds me now on Mars. Isn't Mars a red planet? Just another thing. And the interesting thing is also that what is interesting is that we humans, we need air to breathe, right? Air, vacuum, and breathe. And on the other hand, I know when we have those astronauts like NASA, they're going up into space, and if they go under when they come back to Earth and they do a physical examination, a medical examination, how the physics body is in the conditions, because the person was longer in that no space area. They figured out that a physical body keeps younger. The altering process is slower than on Earth. It makes sense because on Earth we have air. So maybe air is one of the causes we get old. Altering process takes place. That's why we age, we get old. But if you're in the space, the altering process slows down, maybe because there is no air or it's vacuum, right? So you live longer. That's interesting. And another thing about vacuum is, if you put food when you go in a grocery store, or when you store food in a vacuum bag, it lasts longer, right? Maybe some of them like a year, a 2 year, or 6 months, 3 months. So it's a very interesting thing. The keywords: electricity, white light, red light, air, and vacuum. I think if you play around a little bit with those 5 components, you discover interesting things. And maybe that's the reason why I think they want to go to the Mars, because Mars is supposed to be, I think, a red planet, right? A red light, which I figured out on this experiment, my first experiment, electricity. And the good thing is that there was a dark light and it was red, not bright light like this, yellow white, but it was red dark, and it produces a lot of heat. So maybe that's the reason why we try to figure out that the Mars is similar to Earth, because it has air. You see, it's not concealed in a vacuum, it's air. And in those second experiment and third experiment, you see there's a vacuum air. But this vacuum air reminds me now also on the space station, because the astronauts are in those space shuttles all the time on the space station, which is actually to be seen as a vacuum, right? It's very interesting. So this was about how electricity produces light, and a light that it stays as a white light has to do a lot with vacuum, with no air. The air has to go out, move completely away, then the light stays always in a glow status. But as soon air comes into that area, in that space, then the wire, the light burns out quickly and melts down quickly, and then it's gone. So electricity and air and vacuum and light are amazing instruments to create interesting things. So thank you for watching, and I hope you enjoy it. See you next time. Bye.